Okay, we are live. Hello, everybody. Um, OBS seems to be using quite a lot of CPU. Cool. Hope that's not a problem, but probably not. Not gonna do anything particularly resource intensive today, so it should be fine. Okay. And my microphone is working, and my camera is working, and YouTube and Twitch are working. That's not very common that everything works. And here I go jinxing it. Okay. It's time to tokenize. All right. And as always, the number of viewers on Twitch is just made up. There's usually more people active in the chat than there are viewers, according to the stream manager. I would love to start a stream without some sort of technical issue from these godforsaken websites, but here we are. Okay. Today we're actually not tokenizing. That was a little bit of a lie. Today, we are writing C code-ish. We're generating C code. We're generating C code and not dropping stuff off my desk. Let me see. Not a whole lot has happened since my last stream, which was Wednesday. It was 2 days ago. Yep. So, on Wednesday, I was working on this compiler project, and it compiles. Shocking, I know. And it compiles to this thing right here. It compiles this very simple language, which is supposed to be like C. It is C. This is technically valid C syntax. It just isn't inside a function. But it is valid. And it parses it. So it understands the structure of the code. It understands the meaning of the code. For example, it realizes that we are declaring well, this maybe should be called var, not dec. Big deal, it doesn't really matter. We're declaring an integer called y and an integer called x, a label called y loop, and a label called x loop, which is, these four that we're declaring here. And it's technically also checking that all the other ones exist. So if I try to do something like this, where the variable a doesn't exist, it will still compile. Listen, it should complain, but it's not. I changed the logic for this quite a bit. So if it's a check, a var, and a jump. Okay. Do we see the problem in this line of code? I'm just gonna be like my cousin Dora. Do you see the bug? That's right. We are checking that a variable is two different things at the same time, which it cannot possibly be. Yo. What do you mean var x doesn't exist? It's var a that doesn't exist. God damn it, it's one bug after the other. All right, let me see real quick. If I make this normal again and I compile it, it still complains the variable x doesn't exist. Bro, what are you talking about? It's right here. Okay, so I'm gonna have to fix this before I continue. But this is not what I worked on last time. This was actually working fine, but then I had to change the logic a whole bunch, so it broke at some point. We'll have to figure out why. But what I actually said, or what I actually did on Wednesday is generate, well, now it's not working, so I cannot really show, an intermediate representation of the code, which for the time being is just printed. It doesn't really do anything, and it looks like this. I wasn't entirely sure how to go from this to C, because my compiler is not going to create an executable, it's just going to compile to C code. And technically, right now it is C, and it compiles to C, so that sounds a little weird, but it won't always be like that. It will not compile C to C, it will compile something else to C. But the point is we want it to compile to C. For the beginning stages of the compiler, I feel like this is going to be helpful. For number one, I don't have to write the entire compiler myself. Number two, C is incredibly flexible and universal. And number three, it allows me to very quickly check that my compiler is fully working correctly, because I can just compare the source code to the final C code to see if it means what I want it to mean, if, you know, check that everything is fully correct. Also, pretty much all code bases that I've worked on this channel have been to C. And so this way I can integrate my new language into C as quickly as possible by compiling to it. Today we're gonna be actually trying to compile to C. However, we did just see this error. We did just see this error. And we're gonna have to fix it. All right, first off, did I write this fully correct? Well, no, I don't see the issue actually. Unless find symbol, sim type equal type. Right, and you're writing sim type as node T. All right. So what do we want to do? There's two different choices, if you will. You can declare a symbol, or you can check that a symbol has been declared, right? So here we're declaring a symbol, here we're declaring a symbol, here we're declaring, here we're declaring, here we're checking that this symbol exists. This should point somewhere that actually exists. So this is a check, this is a check. This here is two checks. X has to exist in order to assign to it, and it has to exist in order to use it in this operation. X and Y have to exist. Draw should exist, but right now there's no linking of any kind happening. There's no function declaration happening in this language. So for the time being, I'm skipping checking that a function that's being called actually exists. That part is not actually being done, but it should also be checked. This should be checked and this should be checked, but one of them is not being checked. Why not? Well, the easiest thing we can do is check. First off, print a little bit more information, such as the... Oh, you know what it is? Most likely this. Watch me remove this and it will work. There you have it. Okay, I understand. Um, this check actually shouldn't be here anymore because there's no type checking happening at all. And that type checking that was happening before was technically wrong. Uh, Before all the changes that I made on Wednesday, we were checking that a variable called, so actually, like I showed in the symbol here, in the symbol table, it says symbol dec. It used to say symbol var. And so we were checking that there was a var called x or y. But now we're no longer, well, we were still checking for that. The problem is that there's no longer a var called x, there's a dec called x. So because I made that little change, this condition was no longer true, and so it considered the symbol to not exist. In reality, it's not that the symbol doesn't exist, it's that the symbol has a different type, but that's not really true. Type checking is not something I'm particularly doing right now, so for the time being, I'm just gonna get rid of that condition, since also all those names and symbol types and all that stuff is subject to change. So it's really not worth it to update that condition constantly when it's not even being used. I'm just gonna get rid of it, and my code goes back to compiling. So it compiles to this thing right here, which I went through it, and from here, we should be able to recreate some valid C code if we know how to do it. The way that I showed it last time was, we begin with a declaration. We know what a declaration in C looks like. It looks like this. So that's what we're going to have to generate. Actually, you know what? Yeah. A declaration in C looks like this. Or like this, technically, also. Or like this, or something else. But in the very small subset of C which I am able to parse, it looks like this. And if you want to generalize it a little bit, it looks like this, where you have the type of the variable being declared, the name of the variable being declared, and the initial value that is being given to it, which again can or not be an optional. Right, so if you will, you could declare it like this to say, hey, this whole part is optional. Technically, it's not necessary, but we do have it. So we have a declaration, we have a type, we have a name, and then we have an expression, which begins here and ends here. For the expression, we also know what an expression looks like. Again, an expression in C can look like a lot of different things. It can look like this. 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 It can look like this or this. It can get quite complex, but once again, in my very simple language, it can look like one of these options. And again, we know how to parse it, we know how to generate C code from it. And the cool thing about it is that we're actually able to generate it in a somewhat linear manner. That is to say, I can go through these rules that are being printed in a sequential manner. If we see them one after the other, it's because they were generated one after the other. And it makes it kind of trivial for us to generate C code in a very simple manner. Again, it's particularly easy here because we're starting from C code and we're generating C code. After we're done actually generating C code, that can be picked up by GCC and compiled, we can then make it start experimenting with the syntax of the language a little bit and actually changing from compiling C to C to compiling CRED to C. Not entirely sure on the name of the language, but that's what it's called for now. Hi, Stony. Hi, Jester. How you doing? Okay. So another thing that the compiler does is the way that I built it specifically is made to allow for very quick iteration of the syntax of the language. I can very easily change the syntax of the language and even some basic semantic analysis rules and basic code generation rules by changing this text file and recompiling it. Because I use the tagging system to indicate what each element of the syntax of the input language, so this one, corresponds to in the code that my compiler understands. Because the compiler has its own kind of internal representation of code, which is usually called an intermediate representation. It just so happens that the intermediate representation is C-ish. It's technically not C, it's an internal representation that then becomes C. But for all practical purposes, the intermediate representation of my language, of my compiler is C, because then it's meant to be picked up by GCC. And GCC actually does pretty much the same thing. It takes the C language, it does parsing, it does semantic analysis, and then it generates an intermediate representation which gets picked up by LLVM, which then compiles it to whatever architecture you're targeting to create an actual executable. Does GCC use LLVM? Let's say I'm 70% sure of that, but no. It does not. Okay, I was wrong about that. Clang does. Clang. Okay. Clang, which is a different compiler, uses LLVM, but still, that is the way that they work. You start with an input language, you parse that language to understand the syntax of it, you then do semantic analysis to understand that it makes sense what you wrote. So for the example that I showed before that should have failed, actually never finished doing it properly. There's a seg fault now. Oh my god. It's one problem after the other. Alright, I was trying to show, if I change its place, does it actually like, it's still seg faults. Doesn't matter. Anyway, we're gonna have to fix this as well. Wonderful. The point is, syntactic analysis is what I wrote reasonable. If I'm missing a semicolon, that's not valid code, so it's not syntactically valid. If I have a semicolon, but for example, this draw function doesn't exist, that is a semantic error. If both of these pass, an intermediate representation is generated, that gets optimized, maybe even analyzed further, and eventually that gets turned into an executable. This is handled all by the same compiler. It is handled by a compiler and a backend like LLVM, or in my case, it's handled by my compiler, which hands it off to GCC, which does whatever the fuck it does inside. Not using LLVM apparently, but if it passes it to Clang instead, then LLVM is involved. So we have 3 different compilers, if you will. But none of that is important. All right, what is important right now is we have a fucking segmentation fault. Jesus Christ. No. Oh wait, it compiled properly. So I forgot to put the error in. All right, there we have it. In append character, where are we? In analyze rule, print does not exist. That's interesting. Oh wait. Oh wait. Okay, the error is a lot simpler than I thought. I just put an argument here that shouldn't have been there. So yes, quit, recompile, and there we go. Okay, that's fixed. All right, so syntactic error, missing a semicolon, semantic error, a variable that you're using doesn't actually exist. All right, so that works now. Can we see a syntactic error? Does that work? Surprisingly, no. All right, eventually it finds it. And by the way, right before the stream, I made a very simple function that just counts the number of new lines at a specific position that it's been told. And so it can tell you exactly where your syntax error is on line number and column, as opposed to, you know, character number 500. And then you had to do this to figure out which one was character 500. Now it's here. Character 143, actually, it's where it was. So syntax error here, pretty much. Line 8, column 13, which is, it says that it's here. Well, it's technically not accurate, but it's good enough. I'll have to, you know, fine tune it a little bit more. What I'm surprised about is that this is considered valid when I have a missing semicolon at the end. Rust? Is that you? Was that how Rust works? Like, you don't have to have a semicolon on the last statement of the block, something like that. I believe. I'm not entirely sure. Every time I've looked at Rust syntax, I've hated the language more and more. So great. Okay. I saw before, my language is interpreted right now, but I plan to compare to QBE. Nice. Yeah, that is technically the other thing that you can do. This is a compiler. You can also have an interpreter. Actually, what I have is a transpiler. Which means, you know, my compiler has to take hormones occasionally. What it means is it translates source code to source code. A compiler translates source code to executable, and an interpreter takes source code and executes it directly. So it doesn't generate an executable file, it just reads it directly. For example, Python does this. When you write Python, you don't actually generate an executable. You don't have a .exe file, a .elf file, a nothing file. You just have the Py script itself, and then Python picks it up, analyzes it, compiles it, and executes it directly. So in that sense, since mine is a transpiler, about the question that was there before about architecture, doesn't really matter because it just compiles to C, and C is an incredibly universal language that just works on a toaster. There's probably smart toasters that are running C, by the way. You may or may not have one, depending on how many stupid purchases you've made. Please don't buy a smart toaster, people. Please don't buy a smart toaster. But anyway, there's probably toasters running C out there, so that's the cool thing about compiling to C. First off, a lot of the complexity that comes in an actual compiler, I don't have to care about. And like, for example, which architecture do I target? Technically doesn't matter. In reality, the operating system for which I've been building this stuff targets ARM. And so first and foremost, let's say, it's targeting ARM, but the reality is it doesn't really matter, it just compiles to C. That's another reason why I want to skip. Well, I don't want to skip. I want to make a compiler eventually that compiles to an actual executable. But I don't want to do x86 assembly. Please don't make me do x86 assembly. Nothing is better than a Linux driven crockpot until it participates in a DDoS attack. Yeah, so my compiler mostly targets my own operating system, but I am now starting to do cross-platform work as well, which means targeting Intel. And I wouldn't touch Intel assembly with a 10-foot pole. So, yeah. I look depressed? What? Sorry. I'm not. Yeah, for that matter, whether a language is interpreted or not, whether your compiler is that doesn't matter. Like, you can have a C. I've never heard of a C interpreter, to be honest, but there's gotta be some. AC C++ interpreter for scripting computing. There can be C interpreters. For that matter, let's look at the code that my compiler is generating right now. That looks like this. This is just a series of instructions, if we want to look at it this way. For the sake of simplicity, let's ignore the types. So at the end of the day, we don't care about them. I was clutching my head. Oh, because I was talking about x86. Yeah, I was depressed then. I was depressed in that moment. All right. If I wanted to build a machine that interprets this code and just executes it, I can do it. Right? And actually, I went through this entire code at some point on Wednesday, and I interpreted the whole thing myself manually. Today we want to write C instead so that I don't have to do that manually. But what does a declaration mean in this case? That really depends. Like I said, in C, it means something that looks like this. In assembly, a local variable is just, again, whenever I say assembly, by the way, I'm talking about ARM assembly, because that's the only one that I'm really familiar with and the only one that I respect in the slightest. RISC has potential. I just don't know it. RISC-V, I mean. Has potential. I just don't know it. What does a variable declaration look like in ARM assembly? It looks like sub what? It looks like this. Which is essentially reserve some space on the stack to put my variable. That's it. That's what it means. And so there, I just transformed my declaration. And for that matter, I said, let's not look at the type. So I removed that, the type information, but that's actually important. because an integer is 4 bytes. So when I'm going to be transforming this whole thing into ARM assembly, okay, I'm going to be declaring a type int that's 4 bytes. So I'm going to be subtracting 4 bytes from the stack, which means reserving 4 bytes for this variable. And then I'm giving it an initial value, right? With this thing right here. So how do I do that? I can just do this is probably not correct. Yeah, I feel like, yeah, because I'm writing to the next variable, not really to the, so maybe the other way around would be more correct. Which is to say my stack pointer is currently here, write a 0 there, and then move it down. So up here, we now have my variable. Right? So there we go. I just interpreted my C code directly. I just translated it directly to a machine readable instruction. Well, this is assembly written as text, which then needs to be encoded into binary. But if I wanted to, I could just have a machine that does this for me. Right? So whether your programming language is interpreted, compiled, transpiled, is really up to the compiler itself. CJIT is JIT interpreted. There's also PicoC, which is a subset of C but fully interpreted, so you can write scripts in it. Is that used by Pico 8 by any chance? Pycock. You get images of peacocks. No, it is not related to Pico 8. But yeah, essentially at this point, if I want to, I can just directly execute the code, and then I will have made my programming language interpreted with a just-in-time compiler, which means compile and execute immediately. If I wanted to, I'm going to create C code as a result of my compilation process, and then GCC will pick that up and turn it into an executable, or some other compiler could pick that up and interpret it, or do whatever the fuck it wants with it. Or I can just generate an executable myself. I can do anything I want at this point. And for that matter, might expand the compiler to just have all these capabilities. The cool thing about this compiler is it is a, let's call it a little bit experimental. It's not the most efficient. It's not going to be the clearest in terms of errors. But like I said, everything in the compiler, the entire programming language that we can write in here is defined by these rules. And currently, the only limitation that these rules have is that these names here on the left need to always be these. After today, that's no longer going to be a limitation anymore. Technically, I could have already removed it. I just think like what I'm going to do today probably will make it a lot easier to remove it. So I didn't want to bother. I also didn't have a whole lot of time between Wednesday and today. That is technically the only limitation we currently have. Besides that, we can go crazy with the syntax. We can experiment with it as much as we want. As much as the, compiler actually allows, because there's probably still a few bugs that I haven't found, like how I just made it crash and not work at the beginning of the stream. But okay. Right now, what we want to do is we want to generate C code. JIT goes hard. Yeah, it's not really a thing that I'm super interested in. right now. I wanted to compile to something that I don't have to handle the entire compilation process, which is why I'm compiling to C. That way I can experiment with my syntax and I can start integrating it into my projects as soon as I can, as soon as I want. Once I have a clearer idea of the language and whatnot, I will consider all these things and I will expand the compiler a little bit and I'll probably make it better because right now, this is what the parser really looks like. It's an array with all those rules that I said before, which are enums, which is why these names need to be exactly these. You cannot use some others. But like I said, removing that limitation. But even then, it just compiles to an array and then the parser just goes through that array, matching what it finds in the code to what it should find based on what the array says, which is a way of doing it dynamically pretty easily. But for example, when I'm missing a semicolon, please don't crash. It says found syntax error on line 6, column 17, which is, again, pointing here, not really here, but whatever. What is the syntax error? We have no idea because the compiler doesn't really understand what went wrong. I kind of want to see how far I can push it, see how well I can make it detect these kinds of things. But yeah, right now, not exactly the best. Yeah, C is pretty portable. It's just like which library you have. libc makes it pretty portable for Linux and Mac, and then there's Windows, but we're just hoping for it to die at this point. I don't know what else to say. Maybe by the time that I finish an actual game, which is my main reason for doing cross-platform, Windows will be fully dead, and then I won't have to target it anymore. And Copilot OS will take over. Watch it be real. Watch it be real. WSL, yeah. But you know, I would rather. You know what? You know what Steam needs to do? Once they release the GameCube. What they did with Proton, in order to be able to run Windows games on Linux, the opposite. Run Linux games on Windows. And then I can just forget that platform ever existed. Yeah, portable libraries do exist, and yeah. Right now, in my cross-platform stuff, I'm just targeting libc, which I fucking hate. I cannot lie to you, but I haven't looked at these other libraries and whatnot, so I can't really target anything else right now. Whatever works on Windows, whatever doesn't, tough luck. He said, developing a game with this platform, which, you know, most people who game are on Windows. Again, tough luck. Skill issue if you're on Windows, to be honest. Or, you know, you're a Photoshop user or a college student who's required to use Windows for college, or what else? What other excuses can there be to use Windows nowadays? League of Legends player, but honestly, if that's the case, you have bigger issues. Abstraction layer between my language and the C target? Why would that be necessary? I feel like libc, like, it has some issues, like for example for reading files. Pretty sure everything that I've written for reading files will not work on Windows. IDK. It works on Mac and it works on Linux. I don't know about Windows. I haven't tried it. I have a Windows virtual machine, but yeah, I'm still recovering from last time I used it. Audio, yeah. Oh, but I have Raylib. I do have Raylib, which makes that type of stuff a little bit easier. But yeah, file handling, probably an issue. Android is doing good. Android is Linux. Okay. All right, so my IR generator right now, like I said, should be somewhat easy to um, generate C code based on, well, because we have already C code as input and C code as output, it should be trivial in a way to create C code from this code that I have. I kind of thought of how to do it, but I honestly haven't had that much time. And here's the biggest issue that I have. When I'm at this point of this function is where I understand what type of code I'm currently generating, whether it's a declaration, an assignment, expression, function call, argument, conditional, jump, or label. Cool. So I know what I'm doing here. And here, I'm actually gathering all the information to do that. So like I said before, I'm doing a declaration. What do I need for a declaration? A type, a name, and an initial value. So I'm gathering all that information here. And then after that, here, I can actually generate the code. Easy, right? The biggest issue-ish that I have is how to store all that information between here and here, since we don't really have generics, inheritance, or anything like that in C, which is the language that I'm making the compiler in. So that is going to be a thing. And yeah, the Terry Davis used Ubuntu too, I know. Why exactly? Well, let's say that I have a structure to hold my declarations. Again, what do I need to do a declaration? A type, a name, and an initial value, which right now I'm just making it as a pointer type. But what about when I'm doing an assignment? What information do I need to store when I'm doing an assignment? Well, there I just need to store the name of the variable that I'm storing, and again, the expression that is the value of it. SQLite. Nah, I don't know. No, I don't really need polymorphism. And we're trying to make the code as non-OOP as possible. But yeah, that's the thing. If I'm doing an assignment, I'm using this as code over here. If I'm doing a declaration, I'm using this. This is where I store that information. I need to create an instance of this here, store information. Where is it exactly? Here. Well, not really here, but here. And then emit the generated code here. That is where the problem really lies in the fact that I have to do this. And there isn't a single data structure that I can use to do this. And even if there is one right now, for the very simple code that I have in my compiler right now, that is going to expand a lot eventually, and it won't be so easy anymore. But we got to start somewhere. So I might as well just finish writing these. If I'm not mistaken, here they are. Over here, I generated what my compiler's intermediate representation looks like. Essentially what these are, right? So like I said, declaration, where are you? Type, name, and value, right? Let's call it even value. Hey, goldfish. Well, let's keep initial value. That's a good name. All right, but type, name, value. Cool, we got that, right? We did assignment. Which variable to assign to? And expression. Boom, done. What about when you're doing a function call? You gotta know the name of the function. By the way, when I use this token thing, it's just essentially just pointing to the initial source code, since I still have that reference to that. It's just kind of just saying like this, like selecting this part of the code. It's just a lot easier to not have to copy strings around and whatnot. And I always have the representation of the code in memory anyway during the compilation process, so might as well. So I need that, and then I have the arguments. And that is the call code. What about when I'm doing a condition? My language doesn't have else's yet. So to do a condition, we just have the condition itself and the code. What about when we're doing a jump? That one's incredibly easy. It's just a label pointing somewhere. When we're doing a label, very similar, as a matter of fact, even though they're kind of opposite. Well, not opposites. They're complementary. Here you declare, here you use. But either way, label name. And expressions is where it gets a little bit more complicated. Unique ID for names, and then just use some sort of uint instead, which is just an index in the symbol table. Yeah, I know. The thing is that I'm not planning on doing a whole lot of semantic analysis for the time being. So even just the symbol table that you see that's being generated, it's just being printed. Pretty sure it's... No, it is being stored. I forgot about that. It is actually being stored. But it's very limited and honestly not the thing that I want to focus on the most right now. So we're good with just using token for the time being. But you are right about that. Since my point is to compile to C, which is itself source code, maintaining variable names is perfectly fine for the time being. It won't always be, because there will be a little bit of fucking around with that. But for the time being, it's fine. Expressions is where it gets a little bit more complicated, because expressions can have a lot of different things going on. They can have a value, a variable, and an expression or none of that. So it stores this information. kinda, this is what my intermediate representation looks like in terms of like its internal structure. Of course, the problem comes with how to actually keep it. Hey, Ice Dave. Because right now, like using each of these individually sounds like a pain in the ass. I could do something a little bit more ugly, dynamic, but easier in doing like a something like this. And maybe even like a dictionary type of thing, which, you know, C doesn't have dictionaries like this, but let's say it looks like this just to explain what I'm talking about, where you can index it like tokens name like that, but ew, we don't want that. I have dictionaries. I have hash maps actually. So I could implement dictionaries. I just feel like that's an ugly way of doing this. But I haven't really, first off, had a lot of time to think about this, and second, come up with a valid solution even in the little time that I have had about to think about this. Of course, one thing that I can do is have that be handled by the code generator. So, I mean, I probably will be doing it that way. Well, the C code generator, which can hide all of this complexity, but the complexity still needs to be there. So what I'm doing is I'm kicking the can down the road a little bit, but I feel like this is a good thing to do. And in the meantime, it gives me time to think about this. If you have a parse tree or AST, you don't actually need an IR at all. C is your IR. Yes. I mean, that's... yeah. That's what I was saying at the end of last stream. I was just thinking, when it comes to implementing proper IR, because I will want to do optimizations, I'll want to do some kind of static analysis type of thing. I'm just kicking the can down the road further. But hey, you've got a point there. Either way, right now, I do know one thing. I can start creating an interface that this IR generator actually handles. And all of this complexity can be handled by it internally. Okay, Let me see. That's an integer right now. Where's the token stored? It should be in data tokenizer.h. All right. So just to kick the can down the road a little bit, just gonna store these here real quick. But anyway, there's an ad starting, but I feel like I just started. So all I'm gonna be doing during the ad break is just filling out these functions with the same code that I currently have, which is just printing things. Here, moving it to this debug code gen.c so that I can just plug that in to here. No, actually, yeah, multiple implementations is definitely... There we go. Actually, hold on. Keep that where it is. Create a boolgen false. No. Yeah, make it false by default. Then make it true. Here, make it false. Yeah, that's not really valid, is it? Let me skip the logic of this thing for the time being. And where you begin a rule, you just write this thing. You register an element. That just means you... Let's see. First off, let's include the code generator now. Okay, this that I just moved, I'm just going to begin rule using the statement type, begin rule using the statement type, and make this return a boolean, which indicates whether or not this is actually going to be generated or not. So default return false. Because some of the rules don't have any textual representation, so they're not actually counted here. Okay. Here, the code generator's register element. I borrow check, by the way. Ooh. This is your type. We don't borrow here. We just take. Okay. Also, that. Simplify the code a little bit. Take this print with me. How many seconds do I have? 15 seconds. Oh boy. What's your problem? Non-void function doesn't return a value. This should have. Yeah, no, you should return void. I don't know why I made this one a point. Okay, here there should be a end rule with the statement type to keep track of that, but we're not doing anything with it for the time being. Are making declarations their own constructs, or are they magically top-level statements? They're their own construct. Syntactically, they're not different. Semantically, they're pretty different. Okay. So, if I did everything correctly, nothing should have changed. Indeed, nothing changed. Well, actually, a little something did change. Which is that what this used to print a string, now it prints an integer. Because it doesn't really understand what it's looking at. But, yeah, my debug code generator just prints the same thing that it does before. And now I can have my C code generator once I actually decide how I want to build it. Now, there is one thing. In order to have multiple implementations and pick which one you want, there is a syntax for that. Where in the debug code gen, I can just say like that. But I forgot the syntax for this thing. It's a preprocessor thing. No. Let's call it define. See, I hate when I know what I'm looking for. And I kind of could do it without looking at the reference, but I really forgot what it looks like normally. My God, I'm completely blanking on the syntax of this thing. Implementation defined behavior control. If and def. Okay, essentially what I'm trying to do is I want to declare these functions here. I also want to declare them in the C1. Um, but of course, I only want to compile one of these. And I completely forgot the syntax for this thing. Because if I try to compile this right now, it will say I have multiple definitions of it. And essentially, if I'm not mistaken, what I have to do is I have to declare a symbol here. I have to look for a symbol here and only compile this or this based on the implementation. But I don't know how to Google it because I forgot what that is called. And I forgot the syntax for it. I also don't know where to look. Oh no, wait, is it multiple H files or multiple And I'm sure Google would have worked if it wasn't for AI nerfing Google, so this is what I'm looking for, right? No, not really. And once Google was actually a useful search engine, it probably would have given me the answer for what I'm looking for, but thank you, AI. Net negative to humanity. I'm also pretty sure what I'm trying to do is in like header files. Something that I don't think I've actually fully implemented, but God, who remembers? Whatever. Let's just do one at a time. This works. All right. The fact that I'm not able to print this means that there's definitely some information missing. You don't know that this is a type. You don't know that this is a... I guess who knows that would be the code generator. And the code for this used to be what exactly? This. If it was a declaration, you do this, otherwise you do this. I do it wrong? No, type name val type name val name. No, okay, it's correct. All right, so that's back to working. I'm not sure that this is the valid syntax. I feel like there's a more elegant way of doing this. Just do this, pretty much. It's better than commenting out code, I guess. If I don't have this, then it produces this. If I have this, not this, then it produces nothing. And what I really do is this. I can just pick which implementation to use. Again, there's a more elegant way of doing this. I'm sure of it. I don't remember it. Of course, if I use neither, bunch of missing functions. Okay, but we have our normal code generator, but now comes the C code generator. Again, using these types, but I don't really want to do that. Because using these types means that every single time I have to know which structure to address or its type or whatever. And that feels kind of dumb. If and if. No, I don't want default. I don't want default. You could just define C code gen, if and if, debug code gen. No, because maybe I want a third type of generator. So I'm good with this. I just feel like the same logic that I have right now can be written in a more elegant way. I just don't remember how to do it for the life of me. And Google is a useless search engine nowadays, so it's either what's in your brain or what AI slop you are fed by ChatGPT or whatever the fuck, which I refuse to use. So, this is what we have. Okay, that's really not the biggest issue. The biggest issue is my code generator needs to be context aware. And most importantly, it needs to do it in a non-ordered manner. Because right now, we're getting kind of lucky in a way, because we're compiling C. But we're getting kind of lucky that a declaration is given to us in the exact same order that C produces it. So when I'm doing a declaration in C, first I declare the type, and then I declare the name, and then I declare the value. And here, in my language, because it's C, I do type, then name, then value. So it's really easy to generate code from that, right? But if I decide to change my language to do this, then all of a sudden that's no longer the case. Or even this, that's no longer the case. So I need to store that information in structures that look like this. But that is so incredibly ugly. And verbose. And difficult to keep track of it to expand. That's the part that I don't like about this. This is where object-oriented kinda comes in handy. Because then these could all be like subclasses of the same type, right? And then they would just be like a type called no, they wouldn't be structs. They would be classes. Code gen. Then you could just do and then you could generate subclasses for each of these that know how to handle this thing. Of course, we don't have that. Sometimes object-oriented programming can be useful. Not gonna lie. This is one of those cases. Yeah, I can do that. Struct inheritance with a tagged union and a manual vtable. It's just ooh, not particularly elegant, exactly, yeah. For that matter, I kind of am planning to do that in my language. Just eliminating a lot of the complexity, even if it means eliminating a lot of the functionality of inheritance, I'm fine with it. But in cases like this, inheritance can be super useful, and so things like those can be useful. Is a perfect case for a sum type rather than subclasses. I'm just thinking, is there a way to structure it without objects entirely? Well, just a bit of bloat to set it up. True. But, again, this is a problem that I want my language to solve. But I guess we're gonna have to do a little bit of manual work here, kind of. In the sense that we're gonna have to write a bunch of boilerplate right now, and then eventually the compiler will handle that boilerplate for me, and I'll be able to rewrite this class specifically in the compiler. And actually, that can be a pretty good starting point for how to handle this thing, right? How to essentially, the code that I'm going to be writing now, which is going to be very boilerplatey, is going to be the prototype for what will be generated once my language can handle this type of thing more elegantly. So I'm writing the backend, and then I'm going to put a coat of paint over it. Lipstick on a pig type of thing. What is your problem? Oh, I changed. We're not cooked. Not by a long shot. Bootstrapping language features, kind of. I mean, the first C compiler was written in assembly, but at some point you gotta bootstrap it. So I feel like, yeah. All right. This function Pretty much. Handled by my thing here. And do we need any other information? Well, yeah, the type. No, just type. Every 2 weeks or so, I completely forget how to write a function pointer. What's wrong with this? First assembler by hand on paper and then punch it into cards. That's kind of what we're doing here. We're bootstrapping a little bit of object oriented. This goes outside. No, hold on. That's still not right though. That's also not right at all. After the identifier? Hold on, let me just look at an existing example of that. I gotta have some in here, for example. I'm pretty sure I have some. Syntax-wise, turn it into a void. Turn it into a function called register. Oh wait, register is a keyword. That's the problem, okay. Right? You do it like this. And then I change the type. But okay, the problem is that register is a keyword. There we go. Okay. Hmm. So now rewriting this in Rust as soon as I'm done. Totally. I love Rust so much. I'm going to create a folder for this. And I was sure the syntax was right. That's what threw me off so much. Not sure if I'm going to put them all in their own file or I'm just going to put them all in. All right. Even I forgot to put a pointer in, didn't I? Hold on, I'm still not entirely sure what I'm doing here, but let's just begin. All right, the function pointer needs to be this structure, and that structure with that, and this, where PTR can be this or that. Okay, so this is what it would look like for the initial one, and then you need to create this function now. A little bit hacked together, but wait, you don't include your own header. No, yeah, that's not right at all. You don't return a pointer to begin with. You return a structure, which is a codegen_t. That structure has pointer to deck. It has a registered element, which is this, and it has a type, which I forgot to pass in as a parameter, an integer. An OS in Rust is probably not a good idea. You can, but everything's just gonna be unsafe, so what's the point? Okay. Generate declaration with a type. and include the no, C code rules general.h. All right, that was a whole lot going on. C89 feels like a scripting language. Is the best thing I've heard. Even comments are weird in that one. Okay. So how do we know if this worked? Well, put a little print here. And can we run this? Yeah, but it didn't do anything because... No, I do have the C code gen. The C code gen creates the declaration, registers the element, which, by the way, it should probably check if this function actually exists, just in case. And calls it, and then that should be getting called. But it's not. You're returning a valid value with a valid pointer, which is being passed in here. You're printing that. But you're not actually printing anything. Also, this kind of wrong. Let me see if this function is being called. Who cares if that's not spelled correctly? It's not being called. Register lm if def c code gen is defined. Oh, wait. There we go. Like I said, some rules are not code generated, so yeah, this function returns something or not, which is kind of dumb. I can get rid of that now. Instead of relying on that, you rely on the CodeGen T CodeGen. This should probably be declared here. No, it shouldn't. It should not. Forget what I said. This does not go here. All right. Okay. So it's declaring everything for a declaration right now, which is not right, but it's okay for the time being. because I need to create these functions for all of this. But before I do that, I need to consider a little something that I kind of had together, and it's this. The actual type is right now just static. Should it be manually allocated? Oh my god. Should probably be malloced. You know what? Yeah. For the sake of this, I have to malloc it. Which, I guess makes sense. Yeah, it's fine. Which means I'm mallocing a bunch of stuff that I'm then not using, but oh well. I'm also not freeing it, but the process is done by this point, so we're good. And mallocing is probably the best thing I can do in this case, so I'm okay with this. All right, everything that I just did here, let's look at it like this. In my language, could be translated to, for example, with the implementation being in here. And where the code would be this one here. And actually, the initializer isn't even required. So in my code, it can look like this. The reason I'm starting to think of what the syntax of my language should look like, and so I've gone, or I'm trying to. So far, I've only done this for my build system, which I don't think I even committed to Git, or really saved anywhere. I hope I saved it, but I don't think I committed it to Git, so I don't think I can show it because I was doing that on my laptop. Yeah, here it is. Redbuild.cred. Okay. Actually, you know what? I'm going to very quickly commit this to my repository from my laptop, and I'm going to show it on here so I can explain what I'm talking about. Example, okay, there we go. Pull the latest changes and push. Check and then pull. Great. And now I should have an examples folder. So this thing that I'm doing here can go in examples. All right, so essentially I'm just trying to go through my projects wherever I encounter some syntax in C that I don't particularly love. I'm going to think, how would I write it if I'm designing the language? Because that's the fucking point of what I'm doing. And so everything that I just did, code gen, inheritance, I would do it like this. I would have a class inherit from code gen, which, by the way, I should have also included in here. The code gen type, which is declared. Where the fuck did I declare it? Oh, did I just? Yeah, I removed it when I shouldn't have. Okay, that's the problem. That's why I couldn't find it. No, not even that. Um, all right, so this is what I want the syntax of my language to look like. Writing a compiler for C, but fixing things you don't like about C along the way. The reason that I'm writing a compiler for C is that I have to have a starting point somewhere. And ideally, I would want to make my language kind of progressively evolve from C. And I want to make it a superset of C. Not necessarily a spec compliant C like C99, which is what I've been writing, but a subset of C99, which is the one that I've been using. So if C99 declares some abstract, not abstract, sorry, if C99 has some obscure feature that I don't know about, that I've never used in my code, I'm not going to implement that. I'm going to implement a subset of C that compiles my code. And then I'm going to expand it however I want. So I'm going through my projects, and wherever I see something that I don't particularly like, how would I write it properly? And in this case also, how would it translate to C? And that gives us a starting point for designing this language, right? So how would I solve this problem if I had a very basic inheritance system in my project? Well, I would have a CodeGen class, which is the parent one, a language that intersects with C. Intersects is correct, yes. That is exactly how you should think of it. I have a parent class CodeGen, and then I have a child class DecCode, which may not even be an inherited version. It may just be an interface for that matter. Like let's say I just make it an interface, right? So there is no such thing as a parent class. It's just an interface that then gets implemented by this class. That way I don't even have any kind of specific inheritance like that. And how does the language work? I haven't decided yet. That's why I'm doing this. That's why every time I'm writing code in C and I don't like something, how would I write it? And that's how I'm starting to design the language, right? So yeah, I would create an interface for a code generator that implements this function. And then the interface handles that, right? And one thing I forgot is to include this here. So one possible implementation of this interface is the declaration code generator, which takes a type, a name, and an initial value. When it receives a new element, it registers it as either a type or a name. I also forgot to create one for a subrule, which, by the way, this pointer thing is not part of the actual language. There's a little bit too much. Yeah, no, this is fine. This is fine. Okay, so this is how I would implement it. I would implement an interface called CodeGen. It would have a function for implementing an element or for representing a subrule once that's been generated. And it knows how to handle that in its own internal representation. And then obviously it should probably also have a emit code. The last two YouTube messages are literally question and answer. .cred is the name of the language. It's just C-Red, but yeah, it became cred. I don't know about that name. Don't super love it, but it's there. And the file that I'm compiling from to test, the compiler is street cred, so hey. I think I wrote things like this. Format strings like this. And then initial value dot emit. What the hell was that? And OS and Zig. Someone did that a bit ago. That was a thing, yeah. All right, so this is how I would do my code generator if I had OOP. Which is essentially I would have an interface. The interface would then be implemented by this deck code, and it has its own values. Whenever it's told to register an element, it knows how to register the element. Whenever it's told how to register a subrule, it knows how to register that subrule. And then it knows how to generate code based on that. Simple. The only issue that I have with this is the mallocing. Because so far I've been able to... I've been able to avoid malloc until today. Today I wrote my first malloc for the entire compiler. So you can, I think you can understand why I could be a little bit disappointed about this. But oh well. The point is, this is how I would write it in my language for the time being. And this is how I would compile it to C. Right? So this and this would compile to this and the part that I didn't keep, which is this. So, for example, one thing you can notice is that my language's register element, or register elem, has two arguments, a type and an element. Whereas the C-generated version has three elements because it also includes the pointer. So, yeah. Things like those. Also, I would want to do format strings like this. Not gonna lie, big pain in the ass to then translate that to C strings. Let's be clear. But it's essentially gonna need its own parser inside of the strings. But yeah, that is. I feel like modern languages should have this type of thing. They make strings a lot more readable. High level goals for the CRED language. I don't really have any, which is why I'm doing this exercise of anytime I encounter something I don't like, let me write it in a way that I would like, and then that's a goal to work towards. So, for example, I don't want inheritance necessarily, so I have interfaces instead. Which is just to say, you know, not even a poor man's inheritance, just a very basic way of doing it. The other
Red Santar / subscribed to your channel for 1 month.
Red Centaur, thank you for the subscription. I was not wearing my headphones, so I didn't hear that, but thank you so much for the subscription. And for reminding me to put on headphones. So this thing here is quite experimental, to be honest, because I wanted to do a more declarative syntax to customize my build system. That's the other interesting thing. The compiler should be, big should there, should be flexible enough that I can experiment with the syntax as much as I want. I do use a Spanish accent for those and an Italian accent for TTS. By the way. Because I should be able to play around with it quite a bit, I figured a build system should have a pretty declarative syntax, right, in the way that it works. So that's how I wanted to do it. And for example, the output name, which is just used then to compile to a specific file, to pass it as a -o to GCC essentially, is a lazy loaded string. As I wrote this, I also consider like, hold on, how would you translate this to C, like the lazy loading? Because you would need to do, if the variable doesn't exist, then initialize it. But that's with lambda being this. So run this if the variable doesn't exist. But that's kind of just like a lot of well, I guess if you're doing lazy loading, you can do this. I'm just thinking, is there a more optimized way of doing this type of thing? But either way, that's how I would do it. This here is just a function. I was thinking, I even did this here, even though I didn't explicitly mention it. I don't have a return type for the functions here, for the function declarations, or even for the function being called here. Now here it is needed. In the declaration it's needed, here it's not. Essentially, you don't put arguments in the function declaration, and you don't put a return type in the function declaration if there's no arguments and if the function is a void return type. So this comp here is a void no arguments. So make it like this. It gets a lot more declarative like that. This thing here, fail if. I was thinking it's shorthand for if the condition is not met, then print this error, otherwise continue. Which, for that matter, in my operating system code, I have some tests. And I just wrote a very simple macro for something like this. So it could even be a macro, just there's no need for it to be anything particularly complex. I could already have a fail if macro in C if I wanted to. No parentheses in the if. Modern languages like doing that. I'm honestly kind of partial to it. Compiler could also just compile.c files. No, but it produces C files, so those plus the original C files should be fed into GCC. Maybe in the future, yes, but for the time being, no. I mean, let's face it, after I have this initial version of the language and initial version of the compiler, I'm actually planning on making my compiler run in my operating system, because all of the code should technically run in the operating system. The only issue, literally the only one, which is very small, very simple to fix. I was just waiting for a pull request, which I merged today, so I'm going to be able to fix it after today, is the fact that in argv in main, argv0 is the name of the command that was used to run this. Whereas in my system, it's just the first argument. That's pretty much it. That is the only difference between the two. But of course, once my compiler is done, it produces C code, which then GCC is supposed to pick up. So I'm thinking, I don't want to port GCC to my operating system. So instead I was thinking of relying on file sharing, which I currently have between host and guest operating system, to create some kind of system to synchronize these things and start working on a distributed operating system type of architecture, which I've talked about a little bit, but I haven't done anything about. I've just begun thinking about it this afternoon, so let's not get to it just yet. That's not important. Lack of semicolon on line 58 of the red build. Yeah, that's kind of intentional. It should be optional, but this part of the syntax is the part that I am least sure about. Because if you see here, I'm referencing sudo OOP because I wanted to do something like this, right? Where doing an instance of deck code being called as like this should translate to that, right? So that's what I mean by sudo OOP. This translates to, well, not the variable declaration. This translates to this. But what I'm doing here is a little bit different. Essentially, lib is an array. I feel like the language should have an integrated array type because C's biggest issue when it comes to memory management is the fact that you can just index anything. I can just do like, and then I can do this. And this is perfectly valid. Even worse, I can do this. This is valid C syntax, which is insane. Because behind the scenes, what C is doing is just this, pretty much. And so, crazy. Crazy stupid syntax because C doesn't really have an array type. So I feel like there should be an array type in my system. That way bounds checking and all that stuff becomes a lot easier. And you can even chain things together. So lib would be this array type that takes in strings, and then you can add C to it, and then you can even chain more stuff to it, because the type, this is not really the syntax of it. Would look like this. And then it would return itself. That way you can chain it multiple times. That's what I'm trying to convey here, but it would also like this comment here is just like, how do I differentiate this from the pseudo object oriented syntax that I was coming up with before? I have to have a way to differentiate the two. Ideally syntactically and not semantically, but we'll see. Yeah, C is kind of a mess. Yeah, add just returns itself. It's just chaining like that, which again makes the language a lot more declarative. X foo is the same as foo x. Yeah, that's kind of what I'm saying. It's just like gotta keep track of it a little bit. Make sure that I'm doing what makes sense here. Another one is this. I feel like it's kind of a stupid thing. I was thinking like a switch statement as dot switch, but that just looks like another type of function. So just easier to just do switch OS written like this. Instead, you can skip the case word and just do this. Here I wrote it the right way. Yeah, method chaining is something that I want to have. And switch variable. And then you can do this syntax or case do without the break. It just kind of already knows how to do a break. Or even using a variable, a function instead of this. So this here would translate to this. And this here would translate to this. Again, I don't actually have any of this implemented yet, so who cares? I'm just going through things that I've written. I don't like the way that this is written. I want to make it better. And doing that. Self-hosted compiler when the code that I've written here makes me want to do it as quickly as possible. But yeah. Break should be the default. Exactly. Which is why in this language I don't even consider pass-through, to be fair. Just do this. You could also do this, which is most of the fall throughs are really just like multiple cases executing the exact same code. Sometimes though you do want to have it in one case execute this and then this, in another case just this. But we'll get to it when we get to it. Like, not super interested in it right now. Like you said, most of the times break is the intended behavior. A lot of times I've forgotten break. I'm better at it now. But yeah, if you watch my stream even like 2 months ago, you remember me having multiple bugs because I forgot breaks. And it was falling through to the next case. I feel like it should be the default. All right, there's an ad starting on Twitch, so I'll be back in 3 minutes. And now that I've experimented a little bit with the syntax, we are going to well, write the rest of the cases, essentially, as well as the other function that I forgot, this one, and for that matter, this one. All right, I'll be back in 3 minutes. Okay, I'm back. And it's actually getting kind of cold in here, so I have to turn on the heater real quick. And I kind of wish I had a remote so it would make it a lot easier, but oh well. I also wish I hadn't put a bunch of stuff in between me and the heater because now I have to like... Jester heard the heater was being turned on and he came. He wants to be a hot dog. Okay. So yeah, this is the code that I want to have. This is the code that I have for now. This a million times. So the thing is, I should make it a little bit closer to the code that will be generated by this. Because deck code register element will not be called declaration register element. It will be called deck code register element. So that should be its name. Generate declaration should also not be that name. It should be deck code init. Here too. Okay. But right now I only have one, which is the declaration. I need to have more than one. But I also need to have another thing that's completely missing from here is these two not variables, functions that are also part of this interface class. Registering a subrule, because a declaration is type, name, and initial value. It's not required, but that is what it is right now. And of course, something to emit the code is kind of important. Both of which manually take in a pointer to indicate which code we're generating, which subrule we're adding to. And making it point to itself is kind of a pain in the ass. So just do it like that. Start learning C++ to create your own robot OS using ROS2 and a Raspberry Pi. Nice. Happy to hear that. C++ is a pretty good choice. Someone was asking earlier about Rust. You have to wrap everything in unsafe. What's the point of Rust? C++ though, yeah, it's pretty good. Pretty good choice for low level. I feel like Rust for user space is a good idea. Rust for drivers. Come on, man. Well, maybe for drivers, I don't know. But not for the low level shit. Okay. This is what the code gen looks like. And we need to have the register subrule and emit code for the deck. So it's a void deck code register subrule. And a char deck code emit code. Why not use static functions with the arguments? Yeah, I could also do that. It's easier right now because in the actual C code generator, it's literally just this. It's one function call. That's why I'm using function pointers. Once the code is generated and I can afford to make it a little bit better than that, then yeah, I can do it like that. Well, you need to return something. So for now, just return déclaration. Okay. Let's register subrule as deck code register subrule. And emit code as deck code emit code with a comma. What's your problem? think I declared it wrong here. Yep. Why is this green? Oh, it's green because it was created. Okay. All right. We can even create a little macro for this. To make my job a little bit easier. I'm also, yeah, I think I'm not using this type thing for anything, so I'm gonna get rid of it. But this is name. Not sure that's the syntax. Ugh, I forgot how to do this. I've done this a bunch of times in my game engine, so I can probably find it and do it properly, but who remembers? Name. I think this looked like Valix syntax, so I'm gonna keep it like that. I'm gonna get rid of this code thing. I mean, this type thing. I think it's not necessary. Oh. This and this are missing. So we can then just have a code gen declaration for deck code, which obviously is not going to compile because... No, wait, hold on. No, wait, hold on. This is actually compiled like I expected it to. But you have a problem with deck code init. Because I removed the type from it here. All right. Okay. Surprisingly kind of easy. But now, of course, I have to do this for all of these types. I wonder how far I could take this macro thing. If I could do this type of inheritance with just macros, it would be so funny. There is generic. I don't remember which which C version has that. All right, we're now gonna write the ASC code version of this. We already have the ASC code, right? So it's no longer the deck code. You're missing that. ASC code does not have a type. I should also be putting a bunch of checks in here to make sure that everything is correct, but you know, I'm hoping to replace this whole code eventually, soon enough. So and we're of course missing the char ASC code emit with a void pointer returning assignment. Emit code, emit code. Okay. Call code. Very similar to this. except instead of s, it's call. And args that. Conditional code is different because it doesn't actually have any elements by itself. It just has two conditions. And here the type matters. So this whole thing needs to be rewritten. Switching the type on it being a semantic condition, then that goes into the, whoops, this whole thing is missing. Okay. Also, all the variables are called declaration. Damn it. Just gotta call them code. Condition is child. And the default is that the code scope is the child. Again, very easy to break this code, but okay, there we have it. For jumping, it's kind of the opposite. For jumping, we only have a token. We don't have any rules. So JMP code jump equals to elem. That easy. It's no longer called cond. It's now called JMP. Right, and that's good. No sub rule. Jump. The label is very, very similar to it. The difference is just this. And finally, the expression is the most complex one. What can we do about it? exp. It actually shouldn't be too difficult, I believe. If type is, where's the rules? Val or var. Yeah, hold on. XP. If type is sem var or type is sem val, then we save the val. Otherwise, we save the operand. Simple. And here we save the child expression. Cool. I'm thinking of something a little stupid. Okay. I might do it, but it's not important right now. I'm not gonna say what it is until I do it because it's really, really stupid, but really, really fun. Okay. Biggest issue right now is the fact that here I declared 3 different functions. In my code generator, I really only have 2. I have register element, but I don't have register subrule, and I don't have emit code. Right? Which debug code generator. I'm just gonna implement stubs for them because it doesn't really do anything with these. It already is emitting code here, not here, so it's fine. But here I need them. Oh, but they don't have a pointer. Fuck. That shouldn't be there. Okay. How does it work? Well, very simple. If we have a register subrule, then we call it with child. And if we have an emit code, we emit the code. Otherwise, return an empty string. And this type is no longer needed. Except now, this thing right here goes I didn't do one for arguments, did I? The arguments are just expressions, but they're chained expressions. We'll get to you later, arguments. Can't be bothered. And finally, all of these functions pretty much should be declared. All right. What does this do right now? Works. Seems to work. Doesn't crash. Which is not the same as working, but hey, it's good enough. The point is I can now go here and finish plugging everything together. Register subrule. What do I pass in here? This eval rule should return a CodeGen type. I think. I think it should. Okay. You guys return a CodeGen, and CodeGen itself should return a CodeGen type. And should just directly return that. And you should directly return empty. Although you're not really necessary anymore. So now when I call this eval rule, I can return a CodeGen. Here I can return empty, and here I can do that. Not entirely sure. Why do I have a cursor down here? Wait, what was this? I changed it. Here I want to return empty. Oh my god. Yeah, you happy now? Okay. How's that? Error. Line 20 of CodeGen. And the debug CodeGen is completely broken at this point, but that's fine. And we want this check here as well. And that didn't work, or maybe it did, I don't know. GitHub, yes, you can do exclamation point git, I believe, or exclamation point GitHub, or both. GitHub in 2026. What do you mean? Okay, just Git. Just Git. Not both, apparently. Which is not the same as... And, just to be clear. Okay, does it work? I wanna say yes. But how do we know? Well, it's very simple. Well, no, not like that, buddy.
Waffles are better than pancakes.
No, don't agree. Yeah, everything I'm doing here for the compiler is open source. Okay. How's that? No. Still not there, huh? Alright. I guess I have to evaluate the logic of what I'm doing to make sure that it works and it's correct and I finished implementing everything, blah, blah, blah. Okay. I do have Twitter. It's the same as my Twitch. I don't really use it. No, that one you won't find as commands. Okay. Waffles are better than pancakes. They're the same things. Okay, you I think you managed to anger everybody. Congratulations. Isn't the batter the same? I don't know. I don't like waffles that much, so I've never made them. Well, I've probably made them at some point or another, but who knows? Okay. Let me see. Well, this is relying entirely on this type, which is not right. It should rely on gen t, gen, like so. Like so. And like so. And so. Nobody in the world would prefer pancakes. I already said I did. Did I stutter? Was I not loud enough? This end rule thing is not even being used, so I can probably ignore it. Not necessarily, but probably. Anywho. To know if this worked, I can do print. And it prints empty, which I was kind of missing there. Either way. Right, because it generates a blood. Fuck. Not all types will have a child. Will have a type. Will have a thing. A red falcon. And for generating like that, not super valid. And the OS is doing pretty well to the point that I'm now working on a compiler. Mostly just doing like fixes and whatnot nowadays. Even though there is, I'll show it later actually. A big pull request came in and I merged it before the stream, and it has a lot of pretty cool things. Mostly like IPv6 and networking stuff, but also a few things outside of that. Which networking is pretty limited and honestly should be limited because yeah, connected to the internet on that is not the best idea. I mostly want networking for a local network, but still. I'll show it off later. It does have Doom. It crashes right now, and honestly, I haven't taken the time to fix it. But yeah, it does have Doom. I ported it to 64-bit essentially. Didn't consider the fact that the code emitting damn. Okay. When I tell the IR generator to just generate and emit code, it doesn't really keep track of children all the time. So the code is really structured based off of block. Oh no, hold on, this is wrong. Block is the topmost rule, followed by statement, followed by either declaration, assignment, function, call, conditional, jump, or label. These emit code. This and this do not. They also don't recursively go down. So putting the print code here is probably not gonna work. But I can try this, which still does nothing. All right, first off, the macro, where's the macro? Here it is. The macro is assigning a pointer to all of them, which is then being passed to all of them. So we're good. Let me see now if anything here is being done. I should see this log 4 times. I do see it 4 times. And for example, I should see the one in the label 2 times after those 4. And I do. Wait, God, that's really stupid. I did emit code, but not the print emit code. There it is. There it is. Okay. So you know what? I'm throwing caution to the wind, and I'm just gonna do a bunch of allocations and just not care. What does a declaration look like? It's type, name, equal. No, that's it. So what does it look like? The type is token. Wait, hold on. We still need this. I'm gonna call all of these code. Okay, so we're actually generating the code now. Token to slice type. Sorry, code type. Token to slice code name. And then emit code. Code GenT pointer to code initial value. There you go, complaining. Right. Which is supposed to be dereferenced like that. Int y equals expression. Would you look at that? And we can see here that it was, in fact, printed as well, the expression, but it shouldn't have been. So that's kind of a problem. We'll have to fine-tune that later. But right now I have to write this thing about 1 trillion more times. So let me do that real quick. Well, an assignment does not have a type. The rest is the same. And also this declaration, like I said, we're changing its name to code. And the initial value becomes the expression. First time here after name change. Just so I can have multiple. I can hypothetically make more content on the same platform. Because I did want to do some more gaming, which I have been doing a little bit of. And I didn't want to use the same name. Whereas on YouTube, I can use different channel names. Okay. I didn't implement a rule for arguments here. So, we're kind of going to skip over that. God, when did I stop calling them declarations and started calling them code? I think it was after labels, so it's going to be quite a bit. No, here, it wasn't conditional. Code, there you go. You just don't emit anything here. Bada bing, bada boom. All right. What about the condition? For the condition is an if with the code generated by the condition followed by the code generated by the scope. By the way, I'm forgetting a bunch of semicolons. Kind of important. Whoops. Oh, okay. The reason it wasn't giving me an error is I didn't change the type here to to cond code. And now that becomes cond. No, to just to this emit code, this thing. And the same thing for the scope. Right? I jump and label, then expression. So expression is probably going to be very similar to this. I'm just going to copy this code real quick. Okay, jump. Go GT. Go to the JMP code. Code jump. That's the only one. The code for the label is incredibly similar to this one. The difference is that it doesn't have a goto, it has a semicolon at the end, and it doesn't use a jump code, it uses a label code. And it is called just name. And finally, the expression is going to be a little bit more complicated. How do we do this? The expression essentially is if there is an expression, then you generate one type of code, and otherwise you generate another one. I could do some string chaining and whatnot, but that's honestly not worth it. If there isn't an expression, and all you have is just the value, that's all you need to generate. If there is an expression on the other side, then you have to do that, the operand, and then emit the code for the right side of the expression. Boom. Segfault. Hell yeah. What did I do wrong? It's either in the label or the jump. The jump looks fine. That did print properly. Yeah, am I to assume it was the label? No, actually. Am I to assume it was the jump? No. Am I to assume it was the expression? No. Wait, also, labels come way earlier, so couldn't possibly have been that. Well then, look how close we are to generating proper code. Cond code emit code. Cond code. It's the conditional. Right. It's jump and then conditional. Oh, I think. Oh, also right. Code cond. Which one are you missing, bro? Emit code for the code conditional, for the code scope. Yo. How you keep productive? Stream. Good night, Mr. KJ. Four and 0. This is 11, so that's not a good sign. I must have done this switch statement wrong. 4 is an expression, and 0 is none. Wait, why 0? That shouldn't be 0. Oh, wait. There we go. Okay, still, back to the condition. This is emitting nothing. And this one's straight up missing. $11 and 8. 11. And 8. Yeah, those are correct. But why are you not printing them then? I forgot a scope doesn't print any code. Oh god. But also the expression is not printing any code, which is weird. Bye, MX. It's later than I thought. It's registering them, but it's not actually emitting them. Come on, man, we're so close. We're so close. With a couple issues still. But we're so close. Y1, Y equals Y. Let me just really quickly get these two. Put them here. That was supposed to be begin, not being, but whatever. That's weird. It's not emitting anything. Because it's 0. Let me review my rules real quick. A conditional is an if with an expression and a block. So a block doesn't generate any code. I understand that, sadly. But it should be registering that one at least, the expression. Int y equals 0, int x equals 0, y loop, x loop, x, y, this, draw with arguments not implemented. Okay, I gotta start cleaning up this code a little bit. So, when you register a subrule here, you don't let the subrule print any code itself. So there should be print that indicate, well, should print a condition that in this case does not actually print. No. Mm-mm. Okay. At the beginning, in the scope, it's told to print, but it doesn't actually print anything because it doesn't have anything to print. Okay, no problem. The scope goes to the block. No, the block is the scope. The scope goes to the statement goes to the declaration. The declaration has this pointer. It does have one. So it should print, but it's been told by this not to. So that's the problem. Okay, yeah. And now they no longer emit the previous part of the code. So now they do int y equals 0, xy equals 0, y loop, x loop. This shouldn't be here. They should technically be in here, but they're not just yet, so that's fine. This is not okay. This should go in here. Well, I cleaned it up a little bit, but not fully. But anyway, let me see what I've done so far, and I think I'm gonna continue tomorrow because I'm a little bit tired right now, and I'm not fully understanding what's going on anymore. But there is one thing, a little bit unhinged, that I want to do. I'm actually just gonna comment those out because they might be useful eventually. I'm just gonna clean that up and see what code is being generated here. We have the int y equals 0, int x equals 0. The labels are correct. These are function arguments that shouldn't be here. They should be in here, but they're not implemented, so I understand. It's totally fine. This is actually x plus 1. The 1 is up here instead of here. Kinda not correct. This 100 is part of the condition that goes in here. This go-to goes in here. Same thing happens here, and this should be in here. But we're kind of getting there. We need to fine-tune everything a little bit. Now, let me commit what I have. Starting with this and the other .cred, this sample. Sudo OOP interface example. And then I'm just gonna put a little, well, I was gonna put an error there to indicate that this doesn't work anymore because I haven't updated all the function signatures and whatnot. But pretty sure if you do it, it'll show. So there is an ad running on Twitch while I do the commit. Okay. Besides that, I'm gonna mark it as a work in progress because it's not fully done. It's not fully working. I'm gonna push that. And in 2 minutes, I'm gonna do the stupid thing that I wanted to do. It's really stupid. Actually, let me take a little break. I'll be back in 2 minutes. All right. Ad break is not fully done. It still has 10 seconds left. But all right, we're back. Fully this time. Commit is done. Code is done for today. I still have to debug the things that are missing, but I'll do that tomorrow. We'll have the full code generation, and maybe tomorrow we can start experimenting a little bit with the actual language. We will see. But it is quite late. I want to finish, and honestly, I'm starting to feel a little bit too tired to keep going. But this part I need to finish. Because right now, the code gen object is being created by this macro. But everything can be created by this macro. It can also create this, and this, and this, to create classes in C. This is so stupid. Let's go. All right. So, you give your class a name, you give it properties, and then here's where, you know, it kind of breaks down. Each function needs to be declared as an argument of this template, right? So in my case, easy. But really not so easy. There. Then the name of the function is done as name that. Then the pointer at the beginning from the void pointer is given to you as just name. And then the actual implementation of it. You know what? We're gonna make it a little bit more cute by just doing it like self, not elf. Self is a keyword that Swift uses, but I'm not sure if this as a keyword is gonna be allowed here, so I'm using self, which I know it's not used by C in any way. Elem. I gotta copy this somewhere to not lose it. Subrule. And emit, which is this. Right, so this is emit. This is subrule. And this is lm. I forgot to put name here. And now I just realized all of these are not gonna work. So maybe I want to bring back the original definition of CodeGenDeck here. And this one I'm going to simply define as class. We're going to have to escape all of this stuff here, 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 here. There. Boop, 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 boop. Okay. Class. Deck name. Properties for it. Well, that would be a token name, a token type, and a void pointer. Initial value. This is the first of its functions. This is the second of its functions. This is the third of its functions. Boom. Wherever I put the word code, I replace it with self. And lm is... Oh, I used the same name here. I'm just gonna call it T. We have classes in C, everybody. This is dumb. This is so dumb. And yet, if it's dumb, why does it work? Have you ever asked yourself that? If it's dumb, why does it work? That is so stupid, Jesus Christ. I have to say, it works less than I expected it to work, but at the same time, it works more than I expected it to work. Pretty sure the number of viewers on Twitch just went down by like half. So people saw this and just like, they were like, yeah, I'm out of here. And I can't blame them. I can't blame them. Okay, we have classes in C. I want to get a little bit stupider with it. We can even give these functions names, right? quite like that. Register rule and then emit code. Yeah, but you still don't like that, do you? So what does that generate? Deck name FN1. Yeah, that's wrong. I feel like that should be correct, but it doesn't like it. Yeah, that's a string, so it should be 2 of them. But why don't you like that? Because now it's fine, but yeah, I feel like I'm just making the language server just be like, oh bro, what the fuck? It's not referred to any type. Oh, I changed its name. I didn't do the correct name there, did I? What is it called in the code generator? The let register subrule. Subrule. Is that not a class in C? Without even needing to make a fucking compiler for it. I think it is. Stupidly enough. Of course, the last thing I wonder is, could I make it take an arbitrary number of function element, function implementation, function name implementation? Probably not. Probably not. But I am taking it further. With arguments. Yeah, actually. Boop, boop. Doop, doop. Boom. Arguments. This is bad. Subrule takes these arguments, and the emit code takes this argument. You don't like it though, do you? Pasting formed an invalid preprocessor token. Where? It expands to this, which is correct. This, which is correct. This, which is correct. What's your problem with that? It's cursed as hell, but it's correct. Pasting formed an invalid preprocessing token. PP bad paste. Not to be confused with PP bad taste. I've never seen an error that looks like this before. I think it's just telling me, please stop. right? That would make sense. I mean, this is valid code, right? That's what I can do. I can just copy this. And that is valid code. Yeah, so I'm pretty sure it's just telling me you cannot do this. For the love of God, please stop. Yeah, that's pretty much what it's telling me. Because if you just copy it and paste it, it's fine. Well, for that matter, maybe Clang is complaining, but not GCC. Yeah, GCC is complaining. Pasting this and this does not give a valid pre-processing token. Specifically only here? No, not only there. Okay, well, whatever. We already took this too far. Or not far enough. There's gotta be a way to fix this, right? It's like, what if I just do this? Well, that was a little better. But of course, here I have to remove the parentheses. No, you still don't like it, do you? Oh, wait, type specifier missing? From whom? Oh, because I'm passing too many arguments now. All right. So I got a little bit greedy there, adding arguments to it. But shit, that was a good run. That probably should. I feel like the problem was that actually this is not allowed, and they've got a reason why this is not allowed. They've got a point. They've got a point. I think they know what they're doing, but hey, I can still declare variables like, I mean, declare classes like this, which is kind of dumb. Wait, I just realized I also called it the deck name, not deck code. So it still works. Should I keep it? I'm keeping it until tomorrow. Tomorrow, when I sit down and write more code, I'll decide if I want to keep this or not. It's kind of a little bit stupid, but it's kind of a little bit funny to have created classes in C. Okay. With that, I'm going to sign off. It's been bad. No, it's been good. It's been really good until I decided to create this godforsaken macro, which I feel like, shit, I mean, it does what I want my compiler to do. The difference is that's my compiler doing it, not the preprocessor having classes in C. But hey, I don't think I was gonna say I've done worse with the preprocessor. No, I haven't. I don't think I've ever stooped this low. Yet I'm kind of proud of it, so I'm keeping it. Okay, well, like I said, I'm going to end it here. So thank you so much for watching. And Jester wants to say goodbye as well. And he wants to remind you that the next stream is tomorrow at when, Jester? That's right, 3 p.m. Central European time and 2 p.m. UK time. So in the afternoon tomorrow, it's going to be earlier. Sunday as well, and the Monday as well. I might do some operating system stuff, or I might wait for the compiler to be able to generate proper C code and then do like I mentioned, the kind of starting to make that distributed system type of thing. So being able to communicate with something on the Linux side of the host side of the system, which means also eventually being able to communicate with another machine on the local network. But it's quite complex. I haven't yet decided how I want to do that, but maybe I will start thinking of the whole process on Monday. And yeah, working on that. I'm saying Monday because I feel like probably the code generation will be done by then, and we will have some very basic code generation going. But we will see. All right. Thank you so much, everybody, for joining. I'll see you to wait. Hold on. Let me drop a link to Discord in case you want to join. Although I was told that somebody couldn't join because the link was wrong. So I got to check that it works. I'm already in my server, obviously. But it took me to it. So it looks to me like the invite is right. But if I go to incognito mode, it also takes me to the correct place. Yeah. Okay, I think it works. Anyway, thank you so much for watching, and I will see you tomorrow.